This is part 2 of a 2-part video series on how to determine the trigonometric function values for angles on the coordinate plane. The first video should be linked in the top right corner. Before we do an example though, we should talk about in which quadrants are your trig function values positive. In the first quadrant, sine and cosecant, cosine and secant, tangent and cotangent are all positive. In the second quadrant, just sine and its reciprocal cosecant. In the third quadrant, just tangent and its reciprocal cotangent. And in the fourth quadrant, just cosine and its reciprocal secant. How do we remember that? All students take calculus. All trig function values are positive in the first quadrant. Students S, sine, and its reciprocal are positive in the second quadrant. Take, tangent, and its reciprocal cotangent are positive in the third quadrant. Calculus, cosine, and its reciprocal secant are positive in the fourth quadrant. Yeah, I know that's not really a true statement. Not all students take calculus, but that's what people use. If you don't like that, then come up with your own statement. But you just need to remember which values are positive in which quadrant. And in case you need a refresher, quadrant 1, 2, 3, 4. Before we do a triangle example, let's try to apply what we just learned. So let's name the quadrant. Name the quadrant where sine is negative and cosine is positive. Let's talk about this part here first to help us narrow down our two quadrants. So all students take calculus. In the first quadrant, all of them are positive. Cosine's right here. So in the first quadrant, cosine is positive. Second one, no. Third one, no. Fourth quadrant, calculus. The C part stands for cosine. So in the fourth quadrant, cosine is also positive. All right, well, out of those two quadrants, where is sine negative? Well, in the first quadrant, they're all positive, so that means we have to be in the fourth quadrant. All right, next example. Name the quadrant where tangent is greater than 0, that means positive, and where cosine is negative. So let's talk about this part first. Where is tangent positive? In which two quadrants? They're all positive in the first quadrant. All students take. Tangent is positive in the third quadrant. Okay, out of those two quadrants, where is cosine negative? Well, cosine's positive here because they're all positive in the first quadrant, so that means we must be in the third. And the final one, name the quadrant where tangent is less than 0, so where tangent is negative, and where secant is greater than 0, where secant is positive. So secant being positive is the same idea as cosine being positive. Secant and cosine are reciprocals. So where's cosine positive? All students take calculus. Out of those two quadrants, tangent is positive in the first quadrant, but negative in the fourth. Ooh, sorry guys, that was a little low, but hopefully you got the picture. All right, let's apply that to the triangle problems. Reminder, we are going to be doing these steps that we did in the last video now, and we're going to use this in this example. Let theta be an angle such that secant of theta equals -13/5, and cotangent of theta is less than 0. Find the exact value of cosine theta and sine theta. Okay, let's figure out our quadrant here, because remember, it matters how you draw your picture. All students take calculus. Secant is negative, which means that my cosine value is negative. Okay, well, they're all positive here, so cosine's definitely not negative. And the C stands for cosine, so cosine's not negative here either. So this fact that secant is negative means cosine is negative, which means we must be in one of these two quadrants where sine and cosecant or tangent and cotangent are positive. Next statement tells me that cotangent is negative. Cotangent being negative means that tangent is also negative. Okay, well, tangent's positive here, so that means we must be in the second quadrant. Let's draw our triangle in the second quadrant against the x-axis. All right, label your sides. The x-axis is always the adjacent side. The slanted one is always the hypotenuse. So TOA, cosine and secant are reciprocal, so this is flip your fraction. That means my adjacent side is 5 and my hypotenuse is 3. I'm going to deal with the negative later. Use Pythagorean theorem to find your third side. And now deal with your orientation of your triangle to figure out signs. So this is the negative x direction, and this is the positive y direction. And we are always, the hypotenuse is always positive. All right, now we just have to find our exact values of cosine theta and sine theta. SOHCAHTOA. Cosine theta is the fraction, so that would be negative 5 over 13. Also, we could have just flipped our secant fraction. And sine theta is the fraction, so that would be 12 over 13. Okay, before we do this last example, we need to talk about the unit circle very briefly. You may not know what the unit circle is, and that's okay, but all you need to know right now is the unit circle has a radius of 1. Why does that matter? That means that our hypotenuse will always be 1. On the unit circle, your coordinate points x, y straight up tell you your sine and cosine values because your hypotenuse is 1. So the way we set up our triangles, when we correctly do it against the x-axis, your adjacent side will always be the x-axis. The x coordinate is the adjacent side, so the x piece is cosine. The y coordinate is the opposite side, so the y coordinate is the sine fraction. I know we usually think of sine before cosine, sine, cosine, tangent, SOHCAHTOA, but in this case, because of the way we set up our triangles, your coordinate points are written in alphabetical order instead. Your coordinates are written cosine, sine, and that's because our triangle, the way we draw it, the adjacent side is always the x-axis. Adjacent x, so cosine is your x piece. And so these are only triangles or angles on the unit circle can your coordinate points straight up tell you what sine and cosine are. You don't really have to use triangles here. Suppose that theta is an angle in standard position whose terminal side intersects the unit circle at 2, 7, negative 3 square root 5 sevenths. Find the exact value of cotangent theta, cosine theta, and secant theta. Okay, we need to draw our triangles. We have a positive x and a negative y. So in the positive x direction and negative y means that our angle is somewhere down here in the fourth quadrant. You always draw your triangle against the x-axis. Because this is a unit circle, I straight up know that my cosine value is 2/7 and my sine value is negative 3 square root 5 over 7. And so, yes, I did tell you that your unit circle, the hypotenuse is 1, the radius is always 1, so technically we should put our 2/7, negative 3 square root 5 sevenths, and a 1. Notice that both of the h values are the same here. Let's just make a 7 here instead. We're going to multiply our whole entire triangle by 7, all three pieces. It's similar triangles if you remember that from geometry in high school. So is 2/7, so is 3 square root 5 over 7. The hypotenuse is always positive, and then directional wise, this is the positive x direction and the negative y. Label your sides. Now, to find our cotangent fraction, well, tangent is the TOA fraction, which would be TOA. So cotangent, I need to flip that. rationalize your denominator because I do not leave square roots in the denominator. And it doesn't matter if you put your negative at the bottom with the 15 or at the top or just out front. Just make sure this is a negative fraction. Cosine theta was straight up told to us in the problem because this was the unit circle, or if you look at your fraction, your fraction is 2/7. And the secant fraction is created by flipping your cosine fraction. So if they tell you that we have a unit circle, this fraction is the cosine fraction, and this fraction is the sine fraction. Most likely they will have the same denominator, so you can go on and just use your triangle with that denominator as your hypotenuse, just like we did when we did the original SOHCAHTOA video. The only difference here is it kind of matters which quadrant you're in to deal with your signs.